Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to begin our discussion on the first of three topics by talking about the different types of data. And I want to be clear here again that when I'm talking about data in this context, I'm talking about the data that you would associate in the attribute table or the values of a raster dataset, not the vector and raster data structures. And what I want to do is I want to talk about four different levels of data, why we need to worry about this, and what it means from a cartographic perspective in terms of what we can do to the data depending on which level it falls into. So let's go ahead and give ourselves a little bit of space here, and let's talk about levels, categories, or types depending on your preference of data. I'm going to stick with types. We're going to talk about types of data. Okay. And so again, these are the four different categories of data that we can use to explain what we can, I don't want to say legally, but what we can do effectively with the data. And I'm going to talk about what each level is and give some examples. So the sort of lowest level data that we have is what's called nominal. So nominal data would be data that has no numeric meaning. Has no numeric meaning. Right? Another way to think about nominal data would be to think about it as a label. Right? So some examples of nominal data would be things like names. Right? So for example, my name is John, right? That's data, right? It's information, but it has no numeric meaning, right? You can't subtract the name John from the name Susie, right? It also has no ranking, right? You can't say that John is better than Susie or anything of that nature. So let's sort of solidify that, right? It has no numeric meaning, which also means that it has no implied order. And what I mean by order here, I mean rank, right? Because another example of nominal in a GIS context might be the OID, right? The object ID or the FID, feature ID, depending on what software you're working with, right? So another example, names, another example would be OID, FID. Right, that's object ID or feature ID. Right, and in this case, right, there is an order, right? There's 1, 2, 3, right? They're numbered, but they don't actually have any rank, right? The first feature is not necessarily better than the second feature, and so on. So nominal, again, has no numeric meaning and has no implied order. And in this case, order, I mean rank. So one is not better than the other. And examples are names, ID numbers, colors would be another example, right? Red, green, blue, right? These are descriptive information, but you can't say that red is better than green, etc. So another example here would be color. All right. Okay. Nominal is pretty straightforward. The way I like to think of it, nominal means name, right? Or label, and then you can sort of spew out different examples of that. The next level up from nominal is what's called ordinal. Right, is what's called ordinal. So ordinal is similar to nominal in that it has no numeric meaning. right? But in this case, it does have an implied order. Right? And again, by order here, I mean rank. So let's go ahead and talk about some examples of ordinal. So the way that I always remember ordinal is ordinal has order, right? Nominal is names, ordinal has order. And some good examples of ordinal are going to be things like ranked places, right? So for example, if you were to run a race, right, ordinal data might be which place you got. Were you first, second, third, etc.? Right. Another example might be quality. Right. You could imagine that you're out surveying a road network and you have your tablet with Arc Collector open on it, and you have a road in front of you, and you click on the feature, and you're given a list of options for what the quality of the road is. So it might be great, good, okay, poor, right? Right. So with both of these examples, right, they're not numeric, right? First, second, and third doesn't have numeric meaning, even though there's a 1, a 2, and a 3, right? But it does have an implied order because first is better than second, is better than third, right? Great is better than good, is better than okay, is better than poor. Okay, so hopefully that distinction makes sense between nominal, which is names, and ordinal, which has order. And the overarching feature of both of these types of data is no math. Right? I already said has no numeric meaning. What that means is you can't do math, right? You can't subtract, you can't add, you can't multiply, you can't divide, right? Even if we were to take good, great, good, okay, and poor, and we were to code them, which would mean give them a numeric value. So we could say maybe great was 4, good was 3, okay was 2, and poor is 1, right? Even though we're representing these as numbers, because it's just easier to store a 1 byte numeric versus a 32-bit string, right? If you don't, bits and bytes is computer terms, right? Basically, numbers take up less space than text. Moving on, right? If we do this, if we convert from words to numbers, right? These numbers still they don't have numeric meaning, right? 4 does not mean 4. So you can't say 4 minus 2 equals 2, right? Because great minus okay equals okay doesn't make sense, right? So that's what we mean when we say nominal and ordinal have no numeric meaning. It means that the math, even if we were to represent these as numbers, like for example, OID and FID are already numeric, right? You can't do math. The math doesn't make sense. So what I want to do is I actually want to stop this video here. And in the next video, we'll pick up by talking about the other two types of data, interval and ratio. So as always, if you have any questions, please reach out. Thank you.